This video is in response to a comment on one of my previous videos. So this was a video that I had uploaded on the interference pattern from 3 slits, and this was a comment by Amit Kesari. So he had pointed out a mistake in this video, and I'm glad, Amit Kesari, that you pointed out this mistake in this video. So I would discuss the error that I had made earlier and the correct solution to the problem that was posted earlier. So let us recap this question. So this was a question in which we had 3 slits, but they were not spaced out equally. There was unequal spacing between the 3 slits, but the widths of the slits were same, and we were supposed to find out the first principal maximum apart from the central maximum. So here is the diagram of that setup. We have 3 slits, S1, S2, S3. They are spaced out unequally. S1 and S2 have a spacing of D. S2 and S3 have a spacing of 1.5 D. And then we have the screen and we want to see the interference pattern. So how did we solve this question? We had found out the electric field contribution at an angle theta. So this would be sum of electric field components from the slits S1, S2 and S3. So E1, E2, E3 are electric fields from the slits S1, S2 and S3. And then we had considered the reference slit as S1. So field coming from this slit, we will consider this one having the reference phase of 0. Then from S1 and S2, between S1 and S2, there will be a phase difference of delta. Delta corresponding to the spacing D. So we have delta in terms of D as delta is equal to 2 pi by lambda D sine theta. So phase difference is 2 pi by lambda times path difference, and path difference between S1 and S2 would be D sine theta. Similarly, the phase difference between S1 and S3 would be corresponding to the spacing between them D plus 3 by 2D, that is 5 by 2D. So we will have delta plus 3 by 2 delta, that is 5 by 2 delta phase difference between S1 and S3. So here we have written down phase difference between S1 S2, phase difference between S1 S3, and then finally we write down the electric field at the distance at the point P at angle theta. So this is the electric field contribution, and intensity is mod square of the electric field, or proportional to mod square of the electric field, so to say. So here we write down E star E, and then we solve the expressions. I will not go into the details of the maths over here. Let's go down to the final expression for the intensity. So here is the final expression that we have for the intensity, this right here. So this is the final expression for intensity, where delta is given as follows. Now the mistake was made after this. So up until here everything is correct, this is correct, this is all correct. The mistake started from this point, beyond this point, where we had to find out the maximum. So let me point out the mistake first, and then I will discuss why the mistake was made and what is the correct answer. So this is incorrect. This should be delta equal to 4 pi for the first principal maximum, as correctly pointed out by Amit Kesari in the comment. So thank you very much to Amit Kesari. He was the one who pointed this out. So let me discuss the correct solution over here. So let me write down the intensity expression. So intensity expression is as follows. I'm just rewriting it. So this is the intensity expression. Now maximum is going to occur when each of these cosine terms gives us a value of 1. That is the condition for maximum. So maximum will occur when each cosine term equals to 1. So let us see when each of the cosine terms goes to 1. It is not that only one cosine term needs to go to 1. Each of the cosine terms need to go to 1. So the maximum intensity would then come out to be, in that case, E naught squared 3 plus 2 1 1 1 . So this is going to be our maximum intensity. So we need to find out the condition for delta or theta at which we get this maximum intensity. So clearly we can see that the central maximum will occur at delta equal to 0. This is definitely a condition for maximum. Why? Because cos delta is equal to 1. Cos 3 delta by 2 also equal to 1 because it is cos 0. Sorry, not theta, this is cos 0. And cos 5 delta by 2 also is equal to cos 0, which is equal to 1. So each of these terms goes to 1. So this is definitely a condition for maximum. This is but the central maximum. But we want to find out the first maximum beyond the central maximum. So delta equal to 0 is the central maximum. Beyond this, we want to find out the condition for the next maximum or the first principal maximum. Now, as I said, for maximum, this condition needs to be satisfied that each of the cosine term needs to go to 1. So when does cos delta go to 1 after delta equal to 0? Well, cos of delta would be 1 at delta equal to 0, delta equal to 2 pi, delta equal to 4 pi, delta equal to 6 pi, delta equal to 8 pi, delta equal to 10 pi, and so on and so forth. Basically, this will be 0 at delta equal to 2m pi, that is even pi. So cos delta is 1 at even multiples of pi. So this is even multiples of pi. Let me write it again. So this is at even multiples of pi. So this is when cos delta is 1. When is the next term, which is cos 3 delta by 2 equal to 1? Well, this will be 1 at definitely delta equal to 0, but it will not be 1 at delta equal to 2 pi. It will be 1 next at delta equal to 4 pi. Then at delta equal to 8 pi, then at delta equal to 12 pi, and so on and so forth. So this goes in multiples of 4 pi. So this is at delta equal to 4m pi. Similarly, cos 5, the next term that we have is 5 delta by 2. This is also going to be 1 at delta equal to 0, then at delta equal to 4 pi, then delta equal to 8 pi, delta equal to 12 pi, so on, again in multiples of 4 pi. So notice that the common terms, common meaning, each of the cosine terms needs to go to 1. So they will, all three of them will go to 1 at delta equal to 0, then at delta equal to 4 pi, then they will all go to 0 at delta equal to 4 pi, then they will all go to 0 at delta equal to 8 pi, and so on. So all these terms that we have, all these terms, all three cosine terms simultaneously take the value 1, simultaneously take the value 1 for delta equal to 4m pi, that is multiples of 4 pi. So in such a situation, the first principal maximum would occur, first principal maximum would occur when m is equal to 1, that is delta is equal to 4 pi. So this is the correct solution, and not delta equal to 2 pi as I had written earlier. Earlier I had written delta equal to 2 pi. This is not correct. First principal maximum occurs at delta equal to 4 pi. This is the correct answer. Now, why delta equal to 2 pi is incorrect? Let me point out why delta equal to 2 pi is not maximum. Let me point that out in this video. This is because you see that cos delta is equal to 1 for delta equal to 2 pi, but cos 3 delta by 2 is cos 3 by 2 into 2 pi for delta equal to 2 pi. This 2 cancels out. This gives us cos 3 pi, which is minus 1 and not plus 1 for delta equal to 2 pi. Similarly, cosine of 5 delta by 2 is cos 5 by 2 into 2 pi. 2 cancels. This is cosine of 5 pi, which is again minus 1 and not plus 1 for delta equal to 2 pi. So this is not a condition for maxima because the cosine terms are not going to plus 1. In such a case, we will get, for delta equal to 2 pi, our intensity is going to be, first term is 1, second term is minus 1, third term is also minus 1. So we get sorry, I wrote it wrong. This is not 2, this is such. If we see the intensity expression, so this is 3 plus 2 into cosine delta, cosine 3 delta by 2, cosine 5 delta by 2. So this is the expression. So what do we get? We get basically 3 minus 2, which is 1. We simply get E naught squared, which is not 9 E naught squared, the maximum. So see, the maximum intensity I max is 9 E naught squared. We need to reach this in order to achieve our central maximum. But for delta equal to 2 pi, we are only at E naught squared, which is not 9 E naught squared. So this is not a maximum. This is definitely not a minimum condition because intensity is not 0, but it is also not the maximum. Maximum will occur only at delta equal to 4 pi or multiples of 4 pi. So this is the correct answer. This video was just in response to the comment raised by Amit Kesari, the error pointed out by him. So just to address that comment, I have made this video so that people can have the correct solution explained properly once again. So this was a question on 3 slits. Just to recap, so this was a question on 3 slits and finding out the first principal maximum in such a scenario when the slits are unequally spaced, and then we had to find out the intensity pattern and the first principal maximum. In the earlier video, the link to that would be in the description. I had made an error. Now this video is to correct that error.